podcast is not for children. It is a podcast in which four friends get together and we tell each other facts about the world or how we found out about those things about the world that are so fascinating that one of the other people on the podcast will say,
"Holy fucking science!"
Today we are joined, it's very exciting. We are joined by Grant of 3 Blue, 1 Brown.
Hello.
This is cool. I feel like this is our first, no, it's not. We've had proper special guests before from outside.
Craig was on.
Yeah.
Yeah, but you weren't.
I wasn't here for that.
Mm-hmm.
And
I
I
get
have
the impression it's like a regular guests come on kind of thing.
Well, we live, I don't know if you've heard, in Missoula, Montana,
where evidently every science YouTuber ever resides.
Yes. In fact, if you want to move here.
This is what Henry's been mentioning, but
you're wearing Merrill's, which makes me think you belong here.
That's true.
Do you have a Subaru as well?
I once drove more of a... I don't, but I have Subaru roots, you could say.
You have Subaroots.
Subaroots, like the car to learn to drive in and things of that sort. So yeah, I have Subaroots and I have Merrill's, and
yeah,
I'm down to eat roadkill. And from what I understand, that is the requirements for
Ceri did not have a good response to that.
I did not know that. I did not eat roadkill in moving to Montana, and I have want to.
Friends who literally fell in love because they were both they will not eat meat unless it is already dead.
Did they fall in love on the side of a road? There was a deer and they both pulled over and they were about to pick it up. Do you have the permit? You have the... And they bind and and then they share a meal of venison.
Yeah, they're just carving off, you can have the tongue.
Yeah.
No.
No, they were bonding over at a party.
Taste for romance than I do, but it points in all the right directions.
We've also got Ceri Reily. Hi.
Hello. I've been on this before. And
you're a crowd favorite.
Oh, I am?
Yeah.
That's good. That's better than a not favorite.
That's better than what Alyssa's got, which is everybody just is what? Who? Oh, nah. Not actually. Everybody loves Alyssa, too. Mm-hmm. Alyssa and Ceri are the brains behind all the words that come out of my mouth on SciShow, oftentimes.
That's a good way of putting it.
Thanks for that, because this brain isn't doing anything useful anymore. I'm too old for that. And you guys are always hanging out together all day long when Alyssa's in town, because you can't live in Missoula all the time because you're got those deep city roots.
Mm-hmm.
Unlike Grant with his Merrill's. You're wearing Converse All-Stars, which says to me, I'm not ready to go hiking.
I've done that, though.
In Converse?
Yeah.
It's not safe, girl.
I know.
So, Grant, you have a channel on YouTube.
I have a channel.
It's about math mostly.
Almost entirely. I feel like the only non-math video I did was the last one on cryptocurrencies, but pretty much, and that's math, basically, cryptography.
And then you immediately followed it up with a math video.
Yeah, that's true.
That was just because there wasn't enough math in that video, also encryption.
It's I'm down to do other stuff. It's just math is incredibly beautiful. And there's already a long enough list of the things that I want to do that's beautiful math that not enough people know about that is very hard to justify getting distracted in other directions. But yeah, it's called 3 Blue, 1 Brown. And
yeah, and it's I wore your shirt in a video a couple weeks ago.
I was pointed to this by my girlfriend's younger sister. She's did you know? I'm hey.
And man, thousands of thumbs up on the comment, the first comment from somebody who was I know that shirt. So people you got a lot of audience, a lot of fans, a lot of success.
Very, very thankful to my followers and support that they've shown in terms of just the fact that they want more math on the internet, or they're encouraging of
especially good math. And it's such good math. I like it so much.
So pretty.
Yeah, it's really well done.
Math is pretty. Anything, if ever I make something that's pretty, I deserve zero credit, because it's just you get the computer to do what the math is saying, and then all you're seeing is the prettiness of the math.
That's what I always tell. It's a direction we give to SciShow writers is, it's not really your job to be interesting. You have to find out the ways in which the world is interesting and just tell us that.
I like that. I like that a lot. It's a little if you want to carve an elephant, you don't try to think of what an elephant looks like. You just knock off all the bits that don't look like an elephant. The substance is there. You just got to get rid of the rest of the nonsense.
Well, I'll tell you what, living in Montana, when you said carve an elephant, my first thought was you have an elephant and you're turning it into steaks.
Piece of meat that you want to turn into smaller pieces of meat.
Where is he going? I don't like it.
Yeah. More.
Don't kill elephants, you guys.
Don't kill elephants.
There's only one kind of person who does that.
If you take one thing away from this episode, resist the temptation.
Oh God, that's a weird thing to be tempted by. So we decided to do math-related stuff on Holy Fucking Science this week, which we've never done anything like it. I was terrified. I don't know how it did. I'll be interested to see what you think. I'm nervous because I don't have a huge amount of math education. But that is how I want to decide who goes first this week. By the person who goes first is the person who is least educated in math in a formal setting, and the person who goes last is the most educated in math. I took Calc 2. That's as far as I got. I also took physical chemistry, which is a lot of practical applied calculus. Mm-hmm. So that might also count, but I got a D. So I don't know. I feel like it almost got there, but then my grade makes it not.
Was it the thermo side of physical chemistry or the quantum side?
The thermo.
Okay.
Yeah. Have you taken PChem?
I was a physics major, so I took thermo, which is the equivalent of PChem 1, and quantum mechanics, which is the equivalent of PChem 2. Mm. Mm-hmm. Anyway, math education. That's yours.
Yeah. Grant?
I studied math in undergrad and did some of the beginning things that one would in a PhD, but never ended up getting a PhD. So we'll just say BS, period.
BS in mathematics.
Yeah.
Is that?
Or is it a BA? I don't know. Whatever.
I would assume that it's a BS.
Depends on the school.
Yeah, I have a BS in writing,
and I have a BA in physics. So
yeah, that's why. Okay, I actually don't know which is which.
Yeah, but, I have an MS in environmental studies, which is used to what? Huh? Yeah, it's. So yes, but that sounds like you're gonna beat us all, though.
Yeah,
Ceri.
Yep. I had to take through multivariable calculus, so.
I like how begrudgingly.
That's number 3. Usually,
I'm embarrassed to admit I went here. I wouldn't have done it by my own volition.
So I think that I had some linear algebra too. I took that for a little bit and did some matrices, and then was like, no, thank you, and then stopped doing that.
Yeah, I don't blame you.
So.
I don't actually know how to draw the line here. And then you did quantum.
I was a physics major, so I took all those classes, including... I also took a bunch of extra math classes, though, because for a while I was gonna major in computer science, and that needed a lot of math.
Oh, cool.
So I just minored in it instead, but I still took 6 math classes in college.
What was your favorite topic that you wouldn't have usually done?
I really liked the probability course I took, and differential equations was fun also.
I do like probability, because that was in genetics, and I could do that. I made sense in my head.
We did not talk about genetics in our probability class.
Yeah.
There's a lot of applied statistics in biochem, which I was like, yes. And also, yes, this helps me understand everything.
Yeah.
I really feel like probability, just sort of base level probability statistics should be just sort of that to me is more important than algebra. And we can fight about it.
The problem is that one's a requirement for the other, but you can definitely argue it's not emphasized enough. Or that in high schools, often you shoot for calculus. That is the mark of how far you are. But it should arguably be some notion of probability and statistics.
Useful mathematical applications.
Yeah, right now I'm working on probability stuff just because I think that's one of the most important to do in terms of things that should be covered or put out in the world, right?
It's funny, when I made my video, I was talking about probabilities, but about birth control. Right. I think it was a really great opportunity to look at concrete probabilities. And somebody was like, it's almost as if someone knows that someone else is working on an essence of probability series.
That's funny.
So
I should use that as an example somewhere in there.
So, I think you could teach all of statistics just with sex.
Yeah, I feel like you could get...
Why not?
We should do that.
Why not?
Yeah. Well, we'll work on it.
Yeah.
So I have no idea how the cookie actually crumbles when it comes to how educated we are in math. I kind of want to put me last because I did it a long time ago.
That's fair. I'm happy to have you start.
Okay. And then Ceri.
I have less than Alyssa. Probably.
And then I actually don't know where to put you two.
No, you started PhD stuff and have a degree in math. I think you win.
All right, I gotta go first. Mine. Oh man. So I
don't be shy.
You made me nervous
because
you're a math person.
I'm not
I'm not.
I was also very nervous in picking a topic, so you're not alone.
For what it was, I was like, oh, geez, math. I should know a lot of
math
fails,
by the way,
it's hard to think
it wasn't just math. We have decided on math fails. So failures in the world of mathematics. Mine, it's kind of not, but I like it a lot. And when I uncovered it, I was very excited. So there are 2 states in America that are geometrically defined, basically.
Utah?
No. Well, I guess there might be more than 2, but there are 2 that are perfect rectangles.
Oh, okay.
Or they are rectangles, or they are supposed to be rectangles.
Okay.
Which are, anybody?
Wyoming?
Wyoming is one. Colorado is the
I'm
other.
from New York. I don't know geography.
Yeah, New Yorkers know exactly one thing about geography. New York.
Yep.
We know where New York is.
Good.
New York is America.
So Colorado and Wyoming were defined as just boxes based on latitude and longitude. Wyoming stretches from 41 degrees north to 45 degrees north latitude, and from 104 degrees and 3 minutes west to 111 and 3 degrees west longitude. Colorado, 37 north, 41 north, and 102 and 3 degrees, and 109 and 3 degrees longitude. So like just between those latitudes and longitudes, they were like, that's Wyoming and that's Colorado. You would think that they would then be perfect rectangles, right?
That would make sense.
Sure.
But we have 2 problems. The first one is the Earth being round. So latitudes are straight lines. Woo, just straight across. They go right around like a ladder, like a latitude. And that's how you can remember the difference between those things, which is how I do it.
Take
That's
away
good.
from HFS.
And then you've got your longitudes, which are different distances from each other depending on where they are on the Earth. They're furthest away from each other at the equator, and they meet at the poles.
So really, Wyoming should be chubby in the middle. It
So
should look
Wyoming
like
is
got
a
a beer gut.
yeah. It's a little bit bigger at the bottom than it is at the top. Colorado the same. If they were right on the equator, they would be like round on this, like rounded
trapezoid
with
kinda.
like middle would be the thickest and the tops would be thinner. So they are not just geometrically, they cannot be and will never be perfect rectangles. They are not even polygons as defined the way they are defined in the document that passed and said these states will be created, because they have curved sides. They do not have line sides. However, it turns out that they are polygons, because when you make a state, you don't define it mathematically. You don't define it based on, you don't define the border based on like the document that passes and you say the state's going to get made. You define it based on surveyors who go out and in the 1870s basically had astrolabes and compasses and like this weird instrument that I tried to figure out what it was, but I couldn't, called a theodolite, where that like looks at the stars, and you have a chronometer, which is basically just a watch, and you figure.
I'm gonna start calling my watch a chronometer.
I'm sure that somebody does because it's very fancy.
Love your chronometer, by the way.
And so they went out there and they were like, we're going to try to draw the straightest lines we can. And in Colorado specifically, they got to the end, and there was an 8-mile stretch of Colorado left. And they were going south, and it's on. You can look at a map, and on the left-hand side, or the western side of Colorado, about 2/3 of the way down is where they were like, okay, now we have to meet the other border. They were 8 miles away north-south and 1 mile away east-west. So there is a little slanty bit. Which they were like, we did our best.
That's very human.
It's the 1870s.
Try.
And I like that. Despite the fact that it says in the document that created the state, this is how it should be. At this point, the line was drawn, everybody agreed on it, and they're not going to redraw the line.
Yeah.
So this also happened at other places. Like if you actually look at it the way we can now, where the survey markers are, it's clear that every one of them is imperfect. Of course it is, because it's the real world. But so sort of my like last bit here that I enjoyed the most was in the September College Mathematical Journal. 2 mathematicians, Stan Wagon and John J. Watkins, said that Colorado is formed. This is the mathematical interpretation of Colorado. Colorado is a polygon formed by a series of line segments that run between physical monuments that were put in place by survey parties. This polygon has hundreds of sides.
Wow.
So now we know mathematically that Colorado is not a rectangle. It is a polygon with hundreds of sides.
Yeah. Why was it so important that it be a polygon?
What do you mean? It doesn't have to be a polygon. It just is. Because it's drawn on the surface. I mean, it's drawn on the surface of the Earth. And it's a three-dimensional polygon. So it has up and down as well as side to side. Because the border is... Wait. How does a border work? Is a border like exist on the surface of the Earth? Or is the border sort of the idea that extends infinitely to space and sort of on a slice into the core of the Earth?
I feel like that would be kind of the same, right? Like if you draw a line on the surface of a sphere and you like have some sort of like what would extend into space there? I feel like they should be the same.
I don't think it goes infinitely to space.
No, it certainly doesn't go infinitely to space. But
So you don't like
downward...
temporarily own the moon while it's flying over Colorado.
Yeah, Beetlejuice is mine. It's over Colorado at the moment. But like it does matter down. Because like for resources. So if like
I feel like we just beeline straight to the center of the Earth.
You got to beeline straight. So it's not straight down because then you're slicing up Earth weird. I guess it is
straight down. What would straight down mean?
What does straight mean? Yeah.
It's more like
it's
a
straight down to
cone.
the core. So you don't get like sort of a state-sized slice that goes all the way to the core. Like it gets smaller as it gets lower.
It would have to, I guess.
Yeah.
I see what you mean. If you tried to draw, to the extent that Colorado is a polygon, and you tried to like drill into the ground like perpendicular to that polygon, how you might like try to... Well, this is not a great topic for a podcast. I'm like waving my hands all around. Anyway, yeah, could be hard, but just straight line to the center of the Earth, I feel.
But the actual line that defines Colorado, is that a straight line that sort of exists at sea level, or does it go up and down with the mountains?
It's up.
Yeah. That's just, I'm saying, it's more complicated than we think it is. When you try and just draw lines on the surface of the Earth and say, this is a thing now, you're always going to be a little bit wrong.
Yeah, there are.
Also, the Earth moves. Like, well, the whole planet moves, but the ground moves.
Where the ground is.
We just had an earthquake.
Yeah, like those surface markers move apart.
Yeah.
But
has that ever come up in a border dispute that like there are geological shifts between?
But it has to happen eventually.
Like, what's the oldest border that exists that's on a tectonically active region?
And it's just like, my town used to be inside of Kazakhstan, and now it is not. And I don't know why this is a Kazakhstani accident. This was definitely a Kazakhstani accident.
Yep.
Oh. It's been a really long day. It's had a very long day.
So clearly,
if I'm a little silly, I apologize. So that's my weird math fail. Turns out that we thought we were defining a something geometrically, but it couldn't be a rectangle or even a polygon if it was that. But we ended up with a polygon that was made out of a bunch of different human-placed markers.
I feel like that's a
imperfect.
good allegory for like math being applied in general, right? You have this really beautiful and like succinct description of what it should be in the legal docs, and like pat yourself on the back because it's so succinct and unambiguous. Who could disagree with it? And like by necessity, once you hit the real world, it's going to be very different.
Yeah.
Like you can try to understand the extent to which it is an approximation or what that even means.
Yeah.
But just as like a allegory for everything else, where you have this nice purity and people love to think about the purity and they don't want to go too much farther. As soon as it like touches the world, usually through like physics or through computer science, all other things come up that like math folk just don't want to think about because it's uninteresting.
Yeah.
But by uninteresting, I mean like, that gives me a headache. I can't think about that. Right.
Yeah. But real world stuff, like it's not math anymore once it's in the real world.
Yeah.
It's harder math.
Well, it's harder and imprecise math, and you have to think about significant figures and how boring.
Yeah.
But if you want to go look at a map of Colorado, I suggest you do it and check out that sort of like low, like 2/3 down on the west side. There's that little slant. It's very easy to see. It is not insignificant.
Wow. Would you call a circle a polygon with infinite sides?
Oh God! I mean, I literally know a man who wrote a paper on this.
I'm sorry.
And like won
I didn't mean to trigger that memory.
And like, yeah.
What? I feel like that's a semantic issue. Like, where does the paper go?
I don't know. I don't understand. It's math, but his name is Daniel Biss, and he said, and like he proved that like a circle is a straight line or something. I don't know. He did a thing, and using normal math proofs, he was like, turns out circles are straight lines. Like obviously they're not, but.
I mean, it is a handy thing to think
Grant's
of.
like, well, kind of they are.
Or rather, it's handy to think of lines as circles with an infinite radius. There's a lot of contexts where that fact, it's just like you shouldn't think of circles and lines as separate things. And it's just like, no, a line, it's a circle. What's its radius? Oh, it's infinity, but it's a big circle.
I'm just like, everybody go home.
Right. Without that makes, I guess that's a bad thing to say without a clear example of why you would want that, because otherwise you're like, lines are circles, cool facts math, okay, thanks, bye. That's not, you want to show why that would be useful for solving a problem more elegantly.
And that is the thing that I think that Daniel is working on.
Yeah, okay.
Before he quit and went into politics and now is running for governor of Illinois.
Interesting trajectory.
Or possibly mayor of Chicago. I couldn't tell you. Same difference.
I think it was governor.
I think it's governor of Illinois.
Yeah.
He's going to be real mad at me if he listens to this podcast. I'm going to be real mad at him if he listens to this podcast. It's equal. He's busy. He's got too much time.
Yeah. Run Illinois or wherever you are.
All right. Everybody vote for Daniel Biss. Ceri.
That's the new takeaway from the podcast.
Podcast brought to you by Daniel Biss.
Good.
Running for something in somewhere in Illinois.
But maybe not a slanted polygon state.
No, it's definitely defined mostly by rivers and lakes, I think.
Yeah. So I also got really intimidated by the fact of math as the subject. So I did my thing where I fall back on biology because that's where I'm comfortable.
Sure, yeah.
And specifically, the fact that humans share 99 to 99.9-ish% of their DNA. But when you have 3 billion base pairs, that's still room for some difference. And specifically, the difference that forensic scientists are interested in are short tandem repeats, which are basically short units of DNA that are repeated various times. They're usually in the junk sections of DNA, so they're the non-coding parts. And they're a really good way for DNA profiling or fingerprinting because so if you have a 4 to 5 base repeat of ATGC or something like that, you might have 3 of them and I might have 5 of them. And specifically in 13 different regions in our DNA, forensic scientists like looking at that and analyzing them for the number of repeated units and seeing if the blood sample from a knife blade or something matches the blood sample from a suspect. And if you match all 13 of those regions, that's usually a good sign that your DNA matches.
Interesting.
So when you're killing someone, don't cut yourself.
Yes.
Are they is it easier to check for these repeated patterns than it is for all sorts of other things? Or
I think so.
Does the repeated nature of it aid in that?
I think so. The way that they do it, this is off tangential, but yeah, they usually take enzymes that slice out little pieces of this DNA, and so I assume that it's easier to find these repeats, and then they amplify them a bunch and just make a lot of copies of them so that you can
actually
see
detect them.
Yeah, so you can actually detect them, and then I think because it's a number of repeats, then that helps people decipher it. So when you amplify it and run it on, usually gel electrophoresis is the process that they use. You can, if you have different length pieces of DNA, then they run different amounts down the gel. And so I think that helps with the repeats where you have distinct lengths of DNA pieces that you could be looking for.
Bigger molecules that you end up with. And whereas if you're looking at a gene, you can say Ceri and I might have the same gene, but with it one different thing, but it might be roughly the same size. Whereas if it's 3 times bigger or 4 times bigger, that matters a lot, especially with the old systems we had for doing these tests, which was just gel electrophoresis.
Yeah.
Instead of now you can be well, let's just send it to 23andMe and get the entire genome sequenced. Well, not the entire genome, but a lot more.
A lot of it. So a lot of people use DNA profiling and fingerprinting for things, but they're because of the way statistics work, I think. This is where the math comes in, and I'm going to be really embarrassed to describe it.
Bookmark to address the whole math fear phenomenon. At the end
that's
of the
one of the
podcast
things I came across when researching this is that math anxiety is a real thing, and
totally is.
People with the more people think they're bad at math, the worse they are at math, which makes them feel like they're worse at math, which makes them worse at math.
I wanted to do a SciShow on you're not as bad at math as you think you are.
Yeah,
but I couldn't find studies that backed that up because some people are
some
worse
people
at
just
math.
are bad at math.
But also some people are bad at math because they think they're bad at math, but they're still bad at math.
Right. It's not that you're not bad at math. It's that you aren't innately bad at math. Just like I'm bad at drawing, but not because like I'm bad, just because I have never practiced.
Right. Like I think it's not so much it's problematic to think that you're bad at math. I don't mean to interrupt. Sorry.
No,
I'm
go for it.
and we'll come. I just like this is near and dear to my heart, but like to think that being mad at math is a thing is the problem.
Right.
Right.
Well,
it's equally problematic to think that you're good at math, I think, because it eliminates like the sense of growth and the sense of there will be things you run into. Everybody will be bad at math. Every mathematician out there who like has been characterized as a prodigy or whatever it might be had a point they ran into when they felt very bad at math. Right? I think that's as universal as universality gets. But the term here is growth mindset, right? That's kind of like the buzzword to throw around education communities. Like the thought, it's a matter of practice. Like you say, you're not bad at art. It's just this is a thing that usually you don't have a lot of exposure to because you're not deciding to spend your free time doing it. And what distinguishes those who like appear to be good at math or like pick up quickly. Look at what they do in their free time. And there's going to be a little bit more of it allocated, not all for many, but a little more to like random ponderings about patterns. Right? And I think that, and like a history of that back to when you're very young is what makes these differences.
There's also this theory though about like number sense that some people really do are genuinely better with numbers, but that doesn't mean that most of the world is very bad with numbers. It's just that a few people are very, very good with them.
I would want to know whether that's innate, like, a from birth quality, or if it's something that something they did between the ages of 0 and 5, say.
Right, because
like
that's when they
influenced their
start when they start testing it is like 5-ish, because you can't, it's hard to test before that.
Like, I'm a strong skeptic that anything innate exists with respect to math abilities. I could be convinced. I'm like open-minded, but like I am a skeptic against that and would like need to be turned the other way.
I hope that you're right.
Anyway,
That's what I want to be true.
We're testing blood samples and like counting repeatedly.
Testing blood samples. I have anxiety because I'm not used to describing math as frequently, and I'm not confident in my ability to describe it accurately.
And that's what Ceri does for a living. So
Yeah.
it's no fun when Ceri can't describe something accurately.
It's not fair. I just want to be right all the time. And so, yes. But basically the point is that people see DNA as like a silver bullet in forensic science. They think if you have a DNA sample and you have X amount of matches, then of course it must be the killer. Of course this is going to be the evidence that locks in your case. But really, that is false. Like, DNA testing is much, much, much more inaccurate than we think it is, or just like a 80%. Like if you have 12 out of 13 of those regions that are matched, people take that with a much, much greater weight than they should.
Like they assume that means, it's a 12 out of 13 chance they're guilty.
Yeah.
And that's not at all the right interpretation.
Well, also a 12 out of that shouldn't be proof. Give me I mean, there's.
Yeah.
Then you've got every 13 people, you got somebody innocent going to jail.
Yeah.
Right. Yeah.
Yeah.
Is that what it is?
Is there a math fail? Are there a lot of innocent people in jail because of DNA?
I think there's potentially a lot of innocent people in jail because of DNA. So the way that it's calculated right now, or most commonly calculated, is with those 13 regions of repeats. And it's with something called the combined probability of inclusion. And I think the main, this is very vague description of it, but it has to do with general population frequencies of the 13 regions that are included in the set. And then from there, they calculate genotype possibilities. And from there, they calculate like the probability that this is a match to these. But regardless, according to one paper that I read, by the law of large numbers, which is a probability theory, as you increase, I think, the variables, the frequencies of the events with the same likelihood even out. So as you increase the number of regions that you're looking for, and 13 is fairly high, I think, then the probability kind of levels out, and the CPI levels out at about 1 in a million, regardless of the actual mix. So I think what this means in a forensic sense is a lot of time, if you were to take a bunch of like very muddled DNA, like already not very clear samples, and mixed with multiple people, and were to use this probability analysis for it, a lot of the time you would get, well, there's about a 1 in a million chance this person is guilty, and this is an exact match to this trace amount of DNA that we found. Taking into account that this could be fragmented, there could be incorrect amplification here, so we could be missing a zone, or we could be adding an additional zone, things like that. So that is not a very definite chance at all, especially when it comes to convictions. And a 2010 study was like, man, there might be problems with DNA analysis. And so they tried this out and took 17 lab technicians whose job it is to like do DNA analysis. And they took DNA data from a 2002 rape trial in Georgia. And in this trial, the defendant was accused by the co-defendant as like, you were part of this gang rape, which is very sad, very situation. But this is the circumstances of the trial. And the evidence that put the defendant into jail was the fact that 2 forensic scientists said that his DNA was a possible match. It could not be excluded. And that was like the sealing piece of evidence. But when they gave this same DNA evidence to 17 lab technicians and were like, reanalyze this without the emotional circumstances of the trial, do you think this could be a match? One of them agreed with the trial and said it cannot be excluded. 4 said that it was inconclusive, and 12 said this could be excluded, which is just like complete reversal from
100%,
what the trial said. And they weren't sure what to conclude from the study exactly. Mostly the fact that it is just super, super subjective.
It seems, because like even more than a fingerprint, it seems like this is science. This is science. These are guys in lab coats with pipettes, and they've got test tubes. And
like you hear the word DNA, and you hear like a convincing number put next to that. It's just very hard to resist the implications.
The situation is that like, well, I know that I am very different from you, and the only reason I'm though I'm looking at you and I'm like, not that different.
Just give him some glasses.
But the only difference is our DNA. So their DNA must be very, very different, but it turns out it's not very, very different. And that's a scary thing. But I don't know if you know the answer to this question, but like, are there better ways to do DNA analysis now that aren't just gel electrophoresis, which to me seems like something from the 70s?
I'm not sure if I have an answer to that question. I think that's still the main way that people do it, is just like PCR and then gel electrophoresis.
Oh, man, they just gotta send that stuff off to 23andMe
for sequencing.
Be like, first, you're guilty. Second, you're gonna go bald.
Did you know I have some Inuit heritage?
Yeah, you're like
on that fact.
You're like 1% sub-Saharan African. I know you look white, but check that
out. So I think what they're trying to do is account for more of those factors, though. So whether or not, I don't know how much sequencing is involved now, because now it is like really fast and cheap comparatively, but court cases are overwhelmingly expensive and complicated already. But they're trying to take into account more factors. And I think there's a lot of money and time and brain power being put into better software, so that it's not just a forensic scientist.
Some person being like, that looks about right.
I'm going to make a judgment on this, and actually like take into account a lot of the factors that we now know exist, like the fact that mixed DNA is really hard to filter out. Like, it's hard to tell which part is from which person and things like that. Or the fact that contamination between people lasts for a really long time. Like if you shake someone's hand, that DNA can stay on you for a really long time.
Oh, so if I murder somebody after shaking somebody's hand, they could be the murderer. I could pin it on them.
Yeah, and that like
Thanks
there's
for
an
the
actual
tips,
trial.
That's like my mind is going to the place of like, oh boy, like I could be falsely convicted of murder if somebody.
Just shake my hand, Grant. I just wanted to say thanks for coming to Missoula, Montana.
Yeah.
That's
be a
interesting.
strangling
It's a
case in
personality
Missoula.
type. There's two kinds of people out there. Those who worry about being falsely convicted of murder and those who strategize how they can evade the murder they're inevitably going to commit.
That's it.
Watch out, Stefan.
Well, it's okay. We're all in this room, so it's not going to be any of us that get murdered, hopefully.
Well, what do you mean?
I don't know, 'cause we all-
there would be witnesses.
There would be witnesses.
I feel like, on the contrary, this could be exactly the start of a very different direction that holy fucking science goes. Where
Yeah.
it's like, we start off with 4 people in a
The
room
murder mystery.
exchanging facts about science. Next episode, there will be 3. Try to figure out who the murderer is. Like, there's some, like
good.
forensics in there. There's some
That's
like
good clues. That would be a man. If we like spent like 6 months working up and being like, we're just a normal science podcast, and then suddenly there was a murder, and then it was like, figure out from the last 6 months of episodes who the murderer was. Oh, that would be a good payoff.
Yeah. Yeah.
Shame we didn't think of that 6 months ago.
Uh-huh.
I mean,
it can still
shame
happen.
I just ruined it.
Yeah, that too.
Yeah.
Yeah, you have to do it with a different project now. Just start a very different normal YouTube channel, and then
Now-
it turned into murder
Well,
mystery.
Hank never starts new projects.
Yeah,
I
you're
mean,
Yeah.
right.
he only
I'm
has
done
one
with
thing
that.
at a time.
So yeah, like they take things like that and are trying to incorporate it into new software. And I think they're trying to make it more like Bayesian probability, in which you take into account context as a very important factor in the decision making. So, which seems like a very intuitive thing to do. So, like from what I remember about Bayes' theorem and using that, it's like you calculate things based on like what is the probability of you having the disease and testing positive for it, which is like a true positive, and comparing that to the probability of you not having the disease and testing positive, and like all those scenarios, and taking into account all those various different scenarios into your final calculation. And so they want to do that with crime too, is see, okay, this person is already a suspect in the case. Let's see how many of their things match, and if there are any outliers, and then where could those outliers come from, and do that. So I don't know. And are there alleles that aren't explained by the set of suspects? So maybe we should look for more suspects then and take more samples. So whether or not that's eliminating gel electrophoresis and these 13 regions, it definitely opens it up for more looking at different chunks of DNA and things like that. And hopefully fewer false convictions. But it was like a little disheartening to do all this research and be like, oh, here was one where there was a false conviction, and here are 10 more, where it like ended up being a very small sample of DNA that was left over on something else. Or there was one in Europe, in Germany, that was kind of funny, where they were looking for someone who linked together 40 crimes, and it turned out being someone in the swab manufacturing factory whose DNA just like ended up.
Yeah, that's one of my favorite stories.
Yeah.
don't
So-
work at a swab factory.
Yeah.
Yeah, and it
Or
was,
wear the
They were
gloves.
like, there are so few female serial killers, because it was a woman's DNA, and they were like,
Interesting.
this is so weird. This woman's killed 40 people, and it's all very different situations. Some of them are like drug deals gone bad. Some of them are like family murders. Some of them are children. It's just
Yeah.
she just loves killing.
But it was
She
not
doesn't love wearing gloves or whatever, however
Yeah.
her DNA
Yeah.
got it.
what happened. Yeah, so some of them are silly like that, but then some of them are it's like, oh man, this person was actually falsely accused. And
Went
so
to jail for a long time.
yeah,
Oh man.
but
That's why if you ever get convicted of a serious crime,
Hire a lawyer.
you should. I don't know.
Hire a
No.
lawyer.
You have me hanging on my seat there.
yeah.
do
Protest.
take the deal. Take the deal.
Yeah.
Mm-hmm.
You never know what a jury's gonna do. I've seen the shows.
I think you just need to have a bunch of like friends in science, maybe,
Yeah.
because then you can be like, hey, my dude, rerun this gel electrophoresis for me.
Nice.
Revise this algorithm for me.
Yeah.
Or just like when people use statistical arguments, like raise an eyebrow and be skeptical about it. Right?
That's a better draw.
Well, yeah,
that's a
Like
good
the default
conclusion.
tends to be trust it. Science man told me numbers, but like instead say, does that actually make sense? I mean, like the Bayesianism that you referenced, there's kind of this philosophical divide in probability of frequentism versus Bayesianism. And one camp is more or less like take into account what you know already. That's like have whatever philosophical qualms you might have with that, but like that's all we're going to do is just like try to build knowledge rather than viewing each number in isolation. That's not necessarily fair to the frequentist view, but Bayesianism works. And like the point is just like, and the reason is it's like it follows common sense. It's just like, and it's funny how far you can go without letting the common sense point out like that the king has no clothes, right? Or that like the statistics empire has no. It's a tortured metaphor, but you know what I'm saying.
It's not wearing any shoes at all.
Yeah, exactly. The statistical emperor is not wearing shoes nor any clothes. I think that's what I want to say.
Yes.
Oh my goodness.
Be skeptical of everything, including numbers, even though I feel like, numbers are these big weighty things in our society where it's like, it goes back to the circular, like math is a very scary thing for some people because numbers seem like these very objective truths when they should also be questioned.
That video you just did where you're like, oh, like condom failure is 2%.
Of
what does that mean?
Yeah,
like
per what?
Like, it's funny how you can take that part, you're like, okay, and then go on, but like not actually digest, wait, that doesn't make any sense without a follow-on.
Yeah,
right?
I was like, well, I was like, so I should never have sex because like condoms suck. They suck at their job for like a lot, which I mean is kind of maybe the point they're trying to get across.
Like you don't have to lie. I don't know.
Or just
well,
use
you don't
more than one
have
form of
to
birth
lie,
control.
Grant, but they like to lie because they would prefer if children didn't have sex, because that's the only way that there's a 0% chance. Although, now that I've said that, there are ways to get pregnant without having sex, and also like
Hard to do by accident, though.
there.
Except for
It
the-
happens.
But there was that
By
one
accident?
girl who got stabbed after.
Yeah, the stabbing. This is a terrible story.
We're gonna have a lot of terrible stories today.
This woman gave oral sex to a guy, and then then she got stabbed, and
In the
knife
abdomen.
carried the sperm from her stomach into her uterus.
How did it survive? Was it like
It
very...
was. I guess it was very soon after
Yeah.
she had
Jesus.
swallowed the sperm, and like she got pregnant. And she was
Jesus.
like, I can't be pregnant. So that is one way. But in general, if you get semen on the wet parts of the vagina, like it can get in there. And that can happen in a number of different ways. I'm just saying. And people, like oftentimes, there were a number of comments on that video that I removed and wanted to respond to, but felt maybe like it wasn't the right moment, that were like, just do anal, bro. And I was like, well, you can get pregnant from anal sex. Like it can come out and go and get, and then you're like, that wasn't supposed to happen. And I had that conversation with a friend of mine. And she was like, if you get sperm on you can get pregnant just from it being on there. And I was like, I mean, yeah, like it's less likely, but yeah. She was like, shit, it's been on there a lot.
Good.
That doesn't seem like an
Glad you
awkward
were there to
conversation
break
at
the
all.
news.
No, super not awkward conversation.
Uh-huh.
Anyway, Alyssa, how you doing?
My story is not about anal sex. But it is about airplanes.
Math fails.
Airplanes.
So the Boeing 787 Dreamliner, it had some problems.
It did.
It kept having fires. So they grounded it in like 2013, 2014 or something. But then they fixed the problems and they had it flying again. And then they discovered that there was another problem where if you kept the power control units of the plane on for long enough, it would shut everything off. Just, you could be flying in midair,
What's everything?
like the engines.
Oh, that's yeah.
You're like flying through the air, minding your own business, and then you hit this point and there's no warning and everything shuts off.
And did they discover this because that's exactly what happened?
No.
Oh, good.
Thankfully.
Yay, Boeing.
I'm actually not
Job
sure how they
engineers.
discovered. I think it was the FAA was like looking through
Mhm.
the software that they use on the plane, and they were like, "Oh, this bug could be a problem."
And that's
Mhm.
thorough. I feel like
Yeah.
a lot safer flying knowing that a thing like that can be caught.
Yeah.
So it's if the plane is on for 8 months, which is a long time to leave a plane on, but not impossible.
Really? You can leave a plane on for 8 months?
I don't know.
I mean, my computer's been on for 8 months.
It's just like one part of the plane, so it's
Hmm.
like it's just like the power part.
I
of
don't
it,
know
So
what counts as leaving a plane on. Like if you just put it to sleep or safe mode. Like I don't know how do you boot up a plane? I'm sure it happens now
yeah, I don't know.
of
If
something.
they have Android on the planes. now,
Yeah,
I
this-
don't know,
yeah.
built in.
plane Android.
Yeah, I don't know. They have car Android. But anyway, not shilling for Android right now. They figured out what the source of the bug was this thing where, so their computers transfer information certain amounts of bits at a time. So like you had 8-bit, then 16-bit, 32,
Mhm.
64. So 32-bit, like things that are running 32-bit operating systems. So when you have a program, a lot of the time you have to store numbers. And if you store the number as a certain kind of, like as an integer, certain kind of integer, you can't go higher than 2 to the 31 power minus 1. So that's like 2,147,483,647. If the number goes above that, it goes back to 0.
Mm.
So is it just ticking up like seconds or not seconds, but
So
that's microseconds?
that's the thing. The plane was counting the number of seconds that it had been on in hundredths of a second. And
It really is the seconds.
yeah. So if you get up to 248 days in hundredths of a second is one, like that's when you get to the point where it's like above 2.1 billion and it rolls over to 0 and then the plane turns off.
It's like Y2K, but every 248 days.
Yes. So to fix this, they didn't decide like let's redesign the software so there's no bug. The fix is just that airlines have to turn off the plane every 120 days.
I like it to 320 because then if you forget once, you still get it at 240.
I wonder if that
8
maybe that
days
was their
before it happens.
maybe
No,
that
it
was their logic.
definitely is.
Yeah.
That's 100% what it was. I mean, they should have done it every like 124 point. Yeah,
That's such a good example of, like,
123.9 days.
not being willing to change the thing because you don't understand it well enough. It's like, all right, we know the problem. We're afraid if we change it, it'll break something
There'll
else.
be a different
Yeah.
problem.
Everything's fine. Just
Yeah.
you got to do this thing every 120
Push
days.
this button
Yeah.
at least once every 120 days.
It's like the duct tape type of solution, which
Yeah.
is like
Yeah.
a little scary, but it's apparently worked so far because I have not heard
about
of
Boeing just stopping.
Yeah,
Mhm.
as far as I know, that hasn't happened.
No.
So you mentioned, so that's one story of this type of bug,
Mhm.
but you mentioned Y2K,
Mm-hmm.
and this bug will kind of lead to the same problem in 2038. Like Y2K second edition.
Problem.
Yeah. So Y2K, the problem was that when computer scientists first designed computers, they were like, oh, we don't need more than 2 digits for the year. So then after 1999, it went back to 1900 instead of 2000. Turns out that wasn't that big a deal because like we made a big deal out of it and everyone knew about it and they fixed it. And like the worst that happened was like, I don't know, like some data center somewhere wouldn't work or whatever. Like no one died. No one lost hundreds of millions of dollars. The 2038 bug is that Unix-based operating systems, so like Mac and Linux, count keep track of the date by counting the number of seconds since January 1st, 1970. And
That's a really weird way to do it.
It is weird.
It's like January 1st, 1970 is the new AD. Like everything before that is just BC before computers.
Yep.
Yeah, basically. I mean, I don't know about anything that happened before 1970.
I'm not convinced
Some
anything
stuff.
did.
Some things. So on January 19th, 2038, we will hit that number of seconds, and any 32-bit operating systems that are still around that are running Linux or Macs might have some problems. Or we could know about it beforehand and fix it.
Just do an update.
Yeah. Hard to know 21 years in advance exactly what's going to happen. But if...
The good news is by then the world will be over anyway.
Right. Yes.
We will have destroyed ourselves some way.
Yeah. I mean, that's happening like next week. So whatever.
Rapture me.
Yeah. So it's a little bit worrying because if there are still 32-bit systems around, it'll probably be like very basic infrastructure stuff like hospitals or the military, which are not really things that you want breaking.
Well, that's an interesting point. Like the more fundamental to society, the more likely it is to be antiquated.
Yeah. I mean, you go to like
definitely.
in hospitals, they have computers running MS-DOS and stuff like that. Like that's just like normal because
it's like, well, we have this $80,000 piece of equipment that's designed to run with Windows 95.
Right.
And we're going to keep Windows 95 going.
Yeah. So it's a little bit scary. But again, it's in 21 years, so who knows what's going to happen since then. But
Do
till then.
we need to count seconds anymore? Can't we have a better system?
Something else.
Can't like somebody somewhere count, like tell me what time it is and just send the data?
Well, instead of doing that, they use it's 64-bit operating systems. They just use a 64-bit.
There's a lot more bits.
Yeah, so
That's
in
just
seconds.
kicking the can down the line.
Well, no, it's not
64
even.
seconds is going to come before you know it.
It's not even because if you count in seconds with a 64-bit integer, you can go past the end of the universe.
Yeah.
So we'll be okay.
We
should be okay.
A video touching on this sort of thing recently.
I'm sure. I imagine that you would have heard of it.
Part of understanding how big 2 to the 256 is.
Oh man,
it's
yeah,
like
that's
that amount of time came up.
Yeah,
it's like 37 times the age of the universe would be basically 16 billion seconds. So like 64 bits of. Is that right? Yeah, 64 bits worth of seconds.
Yeah, I mean, exponentials is super weird. I was reading a book the other day about self-replicating molecules, and the example they gave was that like this molecule, which is of course the weight of a molecule. I think it was if it was able to like self-replicate unchecked 16 times. So like it would turn into 2, and then its 2 would turn in. It would outweigh the Earth. And it may have been more than 16 times, but it probably not that much more.
Yeah, it wouldn't have to be. I mean, so like 2 to the 16 will be like 65,000-ish.
Oh, okay. Yeah, it's more than that.
So like 2 to the 32 will be like 4 billion.
Yeah.
So that's now you're getting up there. Right? And then if it's like, to the like 40, 50, it doesn't take that many more like
until it is the weight of the Earth.
Yeah. Right? And then you can have some fun with those demos, right? Like, it's like, okay, then if it has to go off the surface of the Earth and like this carpet of bacteria is growing. At some point you get that it's like growing, it's like passing the moon at the speed of light because of all the growth happening within it. Like, way too much fun.
That's pretty horrifying, but amazing to think about.
Well, that's why never base anything on perpetual exponential growth, which is what our economy is based on. So we'll see how that goes.
Yeah.
Hey, Grant, any math fails besides the fact that capitalism is a bad idea? Unchecked capitalism?
Yeah, I appreciate that. I do. So I have 2 different things potentially to discuss, one of which is much more applied and incredibly depressing, which I'll probably do. And then one is just like a pure thing about math itself that only barely qualifies as like math fails.
Okay.
But we'll see if there's time necessarily. So the first one, building off of more legal miscarriage of justice, we have the case of Sally Clark. So in 1999, there was a woman in England named Sally Clark. And a couple of years earlier, her firstborn son died pretty shortly after being born, like a couple months in, died in his sleep. So sudden infant death syndrome. And in 1998, the same thing happened to her second son. And then there was a prosecutor who basically claimed that she had clearly murdered both of her children. And the prosecution rested on the following argument. He says, a woman of her economic standing who doesn't smoke, the probability of a single sudden infant death syndrome would be 1 in 8,500. It says, therefore, the probability of having 2 of those in a row would be 1 over 8,500 times 1 over 8,500, which is 1 in 73 million. Yeah, so that groan is appropriate. But there's multiple reasons to groan at this line of reasoning, and it's worth walking through them. So to put it like, it's a very depressing story because this number was put in front of the jury as it is a 1 in 73 million chance that this happened because of sudden infant death syndrome. The implication being, therefore, she must have murdered her children. She was convicted. She did go to prison. It didn't get past a first appeal, but on second appeal, she was actually freed in 2003. But look, you put yourself in her shoes and where you are psychologically after that happens to you, because it's not just the death of your children, right? It's she was also a solicitor, so like your faith in what you devoted your life to and the legal system is kind of shattered a bit. You've been convicted for killing your children. You have to, that's going to mess with you. And the long story short, she ended up dying of alcohol poisoning a few years down the road. So the reason I bring this up, it's super macabre, but it is a great warning against a couple common fallacies in statistics and in reasoning. So like the groan that you made, talk me through it.
My groan is that that you are taking a population-wide statistic for one thing and applying it to an individual case. And that there are a number of extenuating circumstances that we may have no idea. They may be genetic, they may be environmental, that might affect her children specifically.
Absolutely.
And like, how is that not brought up? That like in SIDS does have a genetic component, and like that's a thing that's known now. Maybe it wasn't known then, but yeah, just like saying like it's a 1 in 8,500 chance times 1 in 8,500 is not how it's. Like so, it's this is a practical individual case. That is a statistic based on like a large population.
So like maybe one of the main issues here is, okay, let's suppose it was 1 in 73 million. There's a million reasons that's not a valid number. Even if it was, the right way to reason about this is not to view that in isolation, but compare it to the probability of the alternative, right? You're comparing hypotheses here. Sure, 2 sudden infant death syndromes is unlikely. How unlikely is double murder, right? That's the number we got to compare it to. And if you, that 1 in 8,500, by the way, he came about, usually the case of sudden infant death syndrome is a little more frequent, but he says because she is non-smoking, because it's affluent family, those same factors make double murder less likely, right? So that doesn't do anything to change the way that they weigh against each other. Everything is a matter of weighing against each other. But even prior to that, let's take a look at this reasoning of probability times probability. So I just made a video on like the faults of the independence assumption. And this shows up all over the place where it's tempting to say the probability of one event and another event occurring is the product of the two. But it's not. That's not how probabilities work. It's the product of the first event times the product of the probability of the second one, given that the first occurred, right? Maybe it's the case that the probability that your son dies in his sleep 3 months after being born is 1 in 8,500. Unlikely, but that happens. But now what's the probability that happens to the second son, right? Well, if there's genetic factors, which there probably are, that's going to be a lot greater, right? It is not another 1 in 8,500. You should be multiplying it by something, but it's not another 1 in 8,500, right? So maybe it's something closer to 1 in 100 because you have demonstrated you are much more likely to have that kind of genetic disposition. So maybe the odds of 2 in a row are 1 in 85,000. Again, that seems like a small number, but the thing to do is not view it in isolation, right? You're comparing against alternate hypotheses. 1 in 85,000 events happen. We're talking about like all of England in this case, or maybe like all of the world. These things happen. It's unlikely, but like the only reason that you heard about this woman was because it did, right? So turns out the same guy had actually prosecuted multiple other women for the same thing.
Wow.
He must have like made it his life mission or something, like, well, clearly I have a master's understanding of probability. And he even had like a little mantra that was like, 2 sudden infant death syndromes is like unlikely, and like 3 in a row is murder unless proven otherwise, or something like that. So like those are two very nuanced issues. I think the independence assumption comes up all the time, especially if you see something distributed as a bell curve. Underlying that is an assumption that certain factors are independent of each other, and they aren't always. So you have like often economic models that predict something is extremely unlikely. They're like, this is 20 significant standard deviations out, and then the thing happens. Like, what was wrong with the model? Usually you can trace it back to an independence assumption. And then more importantly is just when you're making conclusions and you're turning these numbers into decisions, you're weighing hypotheses, right? It is not the case that if a thing would have been like 1 in 85,000 to happen, that means, oh, she must be guilty, right? So that's the case of Sally Clark. It's a good warning. It is, like I said, it's
I'm glad
another,
she's not in jail
illustrate.
anymore.
She's dead. Is
Well,
the problem? Like,
well,
it's
yeah.
She got out
I
of
don't
jail
know,
before
she's-
she died.
I forgot about that. Damn it. And like that was my assumption for what would have happened in jail.
well, also like
yeah.
think about you're a solicitor by profession.
Sure.
You have all this press about you as being a child murderer.
Yeah.
What is your prison experience like?
Right.
You
Yeah,
know?
and even like once you're out, like like how do you can't get away from
Yeah.
that.
Yeah. I'm sure even with whatever acquitted her, whatever evidence, there's still people
Right.
like, parading that false statistic with a false understanding of it and being like, man, something got her out, but
Yeah.
she's guilty in
Absolutely.
my mind.
Do you have something more beautiful for us to end on?
Yeah, okay. It's much more abstract, but it'll be less depressing. So are you guys familiar with the notion of different sizes of infinity?
Yeah.
Yeah, my brother wrote a whole book about it.
But he got it wrong in the book.
Well, okay, let's address that. So
We're gonna fight.
He made a claim like
Well,
He's
John
trying to
says
defend
that he got
himself.
it wrong in the
No, he
book.
did
He
get it
knows.
wrong.
It's like what does the character
Some
say? Like
infinities are bigger than others.
the amount of numbers between 0 and 2 is more than the amount of numbers between 0 and 1.
Yes.
And like all mathematicians are like, no, they're really the same. It's like, okay, they're the same cardinality. There's lots of different ways that you can measure size. And there are reasonable ways where like, yeah, there's more numbers between 0 and 2 than there are between 0 and 1. It's called measure. But like usually when people think about sets and like think of all of their math constructs in terms of sets, those are the same. It's what's called cardinality. It's like the same size of infinity. But I sometimes think people are a little like, the intuitive thing does have another mathematical construct we usually don't think of that goes with it. So like your brother wasn't wrong, or the character voicing it wasn't.
Someone
so
should
wrong.
tell him that.
I'm sure that John wants to get involved in more mathematical disputes about his metaphor.
He doesn't get enough of
basic,
that.
The basic idea is that, so if I count 1, 2, 3, 4, on and on, all of those numbers, all counting numbers, there's infinitely many of them. And if I say, what about how many rational numbers are there? Like 1/2 and 1/3 and 357 over 26. You might think there's a lot more rationals because like if you just go to a number like, oh, they're all over the place, but I only see a handful of counting numbers. There's a nice way to basically put them in one-to-one correspondence with each other. You can make this square dance where like 0 is matched up with 1/2 and like 1 is matched up with 1/3 and 2 is matched up with 2/3. And there's this nice square dance where all of the counting numbers are nicely matched up with a rational counterpart. And that's what we mean when we say they're the same type of infinity. Whereas if I ask how many real numbers are there, so things like decimals, right? Like pi, 3.1415926 and on and on.
Right.
And things like the square root of 2 and all these things. The sense in which there's many more of those is if you try to play this square dance and you say, all right, all of you counting numbers, 0, 1, 2, find a partner. So like 0 matches up with pi and like 1 matches up with the square root of 2. And that no matter what the square dance looks like, there's always going to be a lonely real number. Like you cannot make there's like more real numbers in some sense. Really, most of them will actually have no pair, so most of the reals will be lonely. So
Sad real numbers. Because you could just change one digit at the 3,000th place in pi, and it's a whole other number.
Kind of, yeah. So the math fail, this is like only loosely a math fail, but the reason I bring it up, it's more like math itself seems to be failing us for what we want an answer to be. Because there was this open question about, is there a size that's bigger than the counting numbers, but smaller than the real numbers? So you kind of know, oh, there's more reals than there are counting. Is there something in between? Is there kind of like I'm kind of infinite. I'm not super infinite. I'm bigger than the counting numbers, right? And this was called the continuum hypothesis. And this was an open problem. It was one of, like, David Hilbert has these famous problems that in 1900 in an address, he's like, these are the most important things for math to address. And this was one of those problems. And do you guys want to guess the answer, actually? So the question is...
No.
Yeah, totally.
No, and with the understanding that, like,
Right.
there's no way of knowing what it's going to be without getting deeper into theory. But if you're just a blind guess, do you think, yes, there is an infinity between those two, or no, there's not? So let's raise of hand, or I guess, how many people, podcast, raise hands. How many people think, yes, there is going to be some set whose size is in between those two?
I'll say yes.
I'll say yes because it seems more surprising.
Well, I'll say yes because it seems more likely to be.
That's true.
True.
I don't know.
And
There's a lot of different, I don't know.
Alyssa, you're thinking no?
I'm withholding my guess because I don't know.
That's
Yeah,
a,
I
that's
would just
very,
be a
like,
crapshoot. I don't know the
scientific
answer.
thing to do, but I want you to blindly throw your chips on red and go with it.
Okay, I'll say no because everybody else said yes.
The thing is, all three of you are right.
Yeah,
Okay.
that's the way I wanted to do it.
The answer to the question, and this is the math fail. This is like the universe feels like it's failing us. We're like, hey, universe, I'm going to probe you with theory to try to answer this question. And the answer the universe gives back is like, it could be either one. It's up to you. So like, basically, that question is outside the scope of the usual axioms we use for math. You can construct a theory where that is true, and you'll have a valid, consistent set of math. You can construct a theory where that's false, and you'll have a valid, fine piece of math. And that's weird. That's weird that logic does that to us, that there exist things like that. And I mean, basically it comes down to, like, look, in math, there is no such thing as an absolute truth. It's all dependent on assumptions, on axioms. And just because you have a set of axioms doesn't mean they're going to point to everything you hope will be, like, useful. In this case, I don't know how useful it is to have an infinity that's like between those two sizes. But the same tools that are brought about to answer a question like this are actually, like, useful in other contexts. So that's a very different, more abstract, and I think, like, philosophically thought-provoking kind of math fail, that there exist questions where, given the usual assumptions that we think address all the things we want to construct, still have the answer neither yes nor no. Up to you, bro.
I mean, to me, that's a totally normal thing. Like that's every moment. Like there's always some subjectivity that comes into science, but not in math.
Right. Yeah, that's the thing. Like, you expect this from math. There's a lot, like, if you're talking about, like, holy fucking science kind of things, if you're in biology, you kind of expect them all over the place.
Yeah, like where would chicken or egg? Yeah. Or like when does one species become another? I don't know. Can they fuck?
And you have these, like, crazy cool unexpected things like mantis shrimp or whatever else, and you, like, list all these facts. And you're like, of course, because biology's random. Yeah. Kind of by I don't know if that's a fair statement, but, like, by design, it was brought about through randomness. So you're gonna get weird shit. Yeah. But then in math, which is by design as pure can be, and if you're probing at logic and you're probing at, like, fundamental truths, you don't want these weird things to happen, right? Like, you have situations where, you know, you can have like the quadratic formula that you learn in high school, and for God knows why we tell people to memorize.
Still remember it.
Right?
Don't need to know it.
Nope.
So it's like, here's all the solutions.
Wait till you're 37.
Like a second-degree polynomial. It's like, okay, I don't care. Fine, there exists like a formula for it. There also exists a formula for 3 and for 4-degree polynomials. Turns out 5 and above, there cannot exist formulas. Like, it's not just that we haven't found them, but, like, provably you will not be able to find them. What? Why, math? Like, you're giving that to me at 5? What's special about 5? I would expect this from biology.
The thing that I really want is, like, for it to come back at 9. Like, sure, yeah, no 5, 6, 7s, or 8s, but the 9-degree polynomials, yeah, there's a really quick one.
One of the very first videos I made was, there's this pattern that comes up that looks like it's going to be powers of 2. You're, like, counting this thing, and it's like, in the base case, it's like 1, and then the next case it's 2, and the next case it's 4. And then it's 8, and then it's 16. You're like, yeah, this thing is powers of 2. And then after that, it's 31. And it involves counting, so you're so sure you just missed one, but it's actually genuinely 31. And then it's like 57, and then it's 99, then it's 163, and then it's 256. Yeah! 2 comes back, and then it doesn't hit powers of 2 ever again. But it's like 1 pops up again, right? And you're like, why, dude? Well, there's a reason why, which is why I made a video. But, like, things like
so you'll
this
have to go to 3 Blue 1 Brown to find out.
Yeah.
I forgot to tell everybody that this podcast is sponsored by our beer maker, Big Sky Brewery. Hey, thanks, Big Sky Brewery.
Thanks, Big Sky.
Yeah.
You know, I don't usually like beer.
You're opening your beer now? We're literally ending the episode.
What?
Yeah.
No, I'm just saying.
I mean, you
that
can have it for the road.
Big Sky is,
You're here in Montana.
I'm here in Montana.
That's right.
Mhm.
Give it a sip. You chose like the most beer drinker beer, like somebody who really like likes to drink a lot of beer and wants a lot of flavor.
That's what Big
That's
Sky
the one-
does
that's
to
the
a
one
non-beer
you-
drinker.
that's the one you
That's
picked.
what I tell you.
Yeah, that's not going to taste like a Budweiser. But if you like an IPA, enjoy it. It's very good. I like Scapegoat a lot. And also, hey, 3 Blue 1 Browns out there, full of all of that eloquent math that just happened here on Holy Fucking Science.
That was definitely the most eloquent math. It
Yeah.
was
Oh,
very
that we will
nice.
ever
it was,
have.
It was great to listen to.
Until you move to Missoula.
Until I moved to
Get some
Missoula.
real action out of those Merrills.
Mhm.
Personal ties to the Bay Area, man. What can you do?
I don't know what that means.
Oh,
Are
sorry.
those made in the Bay Area?
No, I was referencing more my life situation. than my shoes.
Oh, you're stuck in the Bay Area due to human.
I'm not stuck. I like it there. I'm just
You're
saying,
you're underwater. You're so tied to that
Just
terrible
trapped.
place
It's a
where
great
no
place.
one likes living at all.
everyone loves it there.
I know. I'm kidding.
Yeah,
Yeah.
I'm just gonna stand up a little for
Where the weather is really consistent and not 100 degrees in the summer and negative 20 in the winter. Sorry.
I tell you what, I
Sorry.
grew up in a
That's
town
okay.
very much like Missoula, so it feels almost nostalgic, even though
Yeah.
I've never been here.
Nice.
There's a nostalgia that comes around.
Yeah.
So
Hey, thanks everybody for listening to or watching Holy Fucking Science. We are wherever podcasts are, and we have no way of telling people that we exist, except for when you tell people that we exist. So if you want to share Holy Fucking Science on Twitter or however you share podcasts, we'll really appreciate that. This podcast was produced or edited. I don't know. Ceri. Nope. I was looking at Stefan in the face and I said Ceri.
We're one person now.
Stefan was on sound. Jen was on camera. I have been Hank Green.
I have been Alyssa Lerner.
I am Ceri Reily.
I have been Grant Sanderson.
And this has been
Holy Fucking Science.